configuration diagram. Okay, and this they have given as 10 radian per second. Okay, so first actually you have to calculate the velocity of point C here. Okay, the velocity of point C. So from this we will construct the velocity diagram. So before proceeding here, first of all, how many fixed points are here? The A is a fixed point and D is a fixed point. So we will take all fixed point as a single point because there is no relative velocity between these points. Okay, so I am taking A and D. A and D as a single point. Why I am drawing here? Because actually it is rotating in anti-clockwise direction. The velocity of AB link will be like this. So I am drawing here. I am not locating here so that I have to draw like this. Okay. So if it is rotating clockwise, I can take here the AD point so that I can draw the vector AB vector like this. Okay. So I am marking here. So now before going to construct this velocity diagram, you should understand because these are the velocity diagram is a vectors. So for any vector we need to know the magnitude and direction. So now here if the link, okay, the link AB, okay, here the magnitude, okay, magnitude you can calculate like velocity of B relative to A is nothing but AB link length into omega. So this is AB is 50 millimeter, so 50 into 10, so this is 500 mm per second. So here to draw this AB vector, we choose some scale for velocity diagram. So I am choosing 1 centimeter is equal to 100 mm per second. Okay, and the direction actually here, the direction of velocity B relative to A will be perpendicular to link AB. Perpendicular to link AB. So how you will draw a perpendicular? Because actually AB link is here, okay, and you have to draw a perpendicular line starting from A because we already know the point A here. Okay, so now I am using this one. Actually for this, actually this and this side and this side are perpendicular. So here I am placing one edge, okay, on the link AB. Okay, one edge on the link AB, so that I am moving this scale like this onto this AD point, so I can draw a vector like this. Okay, so this is a perpendicular line, and here I can mark I am choosing 1 centimeter is equal to 100 mm per second. So 500 by 100, it is 5 centimeter. So I can take a scale and mark B point. Okay, so this is the B point. Okay, so the direction actually you can make a thick line here, so we know this. So the direction will be in this direction, okay, because the crank is rotating in anti-clockwise direction. So you know located B, okay, and here to locate C here, okay, to locate C we don't know the magnitude. Link BC magnitude we don't know, but direction of this velocity is perpendicular to link BC. Okay, so again we draw a perpendicular to link BC. From where we start, we already located B point, so BC perpendicular we will draw from B. Okay, so now here we will place one edge on this like this, and we will move this scale. So this is our perpendicular. So we will draw a line like this. Okay, we will draw a line like this. So on this line, the C point will exist. Okay, so again here, link CD. So we don't know the magnitude, and the direction is perpendicular to link CD. So again we will draw a perpendicular from D. Okay, from D we will draw a perpendicular. So we will place the scale like this. Okay, we will place the scale like this, and we will move the scale okay, and we will draw a line like this. So this is the intersection point will be C point, and the directions, okay, you can make a thick lines of this one. Okay, so this is the velocity vectors. Okay, so this is the velocity vector. To know the directions, the BC direction and CD direction, so you will write the relative velocity. Okay, so the relative velocity of C relative to A, that means velocity of C relative to A will be equal to velocity of C relative to B plus the velocity of B relative to A. Okay, so now here in vector forms, AC vector is the resultant of BC vector and AB vector. So here the AB vector you know, okay, and AC is the resultant, and AB vector plus BC vector. So actually the BC vector will be in this direction, and AC vector is the resultant, so it is the closing side. Okay, the direction you can mark. Okay, so now here the first question is the velocity of point C. Okay, first question is the velocity of point C. So here the velocity of point C is nothing but velocity of C relative to A, which is equal to velocity of C relative to D, because it's an absolute velocity and the AD are fixed points. Okay, so now here how you will measure, how you will know this one. So you will just take a compass, okay, and measure this vector, AC vector. Measure this AC vector, okay, and you can take a scale and measure this AC vector. I am getting like 3.9, okay, I am getting like 3.9 centimeter. So here the 3.9 centimeter, and our scale in velocity diagram is 1 centimeter is equal to 100 mm per second. So into 100, so this is equal to 390 mm per second. So we calculated the velocity of point C. So here, and also here the second question is the velocity of point E. Okay, the velocity of point E. So this is the first one, and second one, the velocity of point E. So how you will calculate, because actually E is the intermediate point, okay, a point on the link. So you know that it will divide equally, ratio of lengths is equal to the ratio of the vectors. That means BE by BC is equal to BE by BC. So the smalls represent the vectors, okay, and capitals represent the lengths. So from this actually you can calculate BE is equal to BC into BE by BC. So BC, actually you can take a compass and measure this BC vector. Okay, this BC vector will be 3.1, I got, okay, 3.1. So 3.1 into 100, because our scale 1 centimeter is equal to 100 mm per second. So into 100 into BE by BC. BE is 40 divided by BC is 65. So here you can calculate the value of this one. Okay, 3.1 into 100 into 40 divided by 65. So this is 190.77 mm per second. So here actually to locate E on this vector diagram, okay, so our scale is 100, okay, 1 centimeter is equal to 100 mm per second, 190 by 100, this is 1.9, so it is a BE vector. So from B, okay, so from B you can measure 1.9 centimeter, okay, 1.9 centimeter, and this point is E. This point is E. Okay, so next question. Next question is the angular velocity of link BC and CD. Okay, so the third question is the angular velocities omega BC is equal to how much? So we know that V is equal to R omega. So omega is nothing but V by R. So velocity of BC divided by BC. So velocity of BC, how you will calculate? Actually here you can measure this. Okay, you can measure this. Anyway, we measured this actually here 3.1. So 3.1 into 100 BC vector, anyway we measured here, into 100 velocity divided by BC is 65. So 3.1 into 100 divided by 65. So this is 4.77 radian per second. So next question is omega of CD. Okay, omega of CD, similarly here the VCD divided by CD. Okay, and you can say VCD. CD here CD and CA same, okay, AC, right? So you can we already calculated VCA and VCD here. So this is 390 divided by CD 55. CD length is 55. So you can calculate 390 divided by 55. So this is 7.1 radian per second. Okay, so the